Our next step is to create name selections. It means that we give names to each and every surface of our domain and to also to our car body, so that they can be used in assigning boundary conditions while we upload our geometry into Fluent solver. So for that we must first select surface. This is our inlet surface, so right click on it and create name selection. We give it a velocity inlet. Also this is our symmetry plane. This is also a symmetry, we call it symmetry top. These are for assigning boundary conditions. You must have the knowledge about all these terms. Without proper knowledge you cannot sorry, I should call this a symmetry side, as this is to our side. Okay, so I was saying that you should have knowledge about this, because without proper knowledge or without proper literature study you cannot get accurate results. This is our pressure outlet. And one more surface is our road. Okay, so we have created our name selections. Now another thing is that if you want to create an inflation layer around your car body so that you can accurately capture the boundary layer effects, it is generally very useful. So we will also try to create an inflation layer around our car body. So under inflation tab, here use automatic inflation, we will select program controlled inflation. Here it asks about maximum layers, so 5 is quite good. Growth rate is 1.2, so it's okay. Now another application of these name selection is that from here you can also, if you create these surfaces, now you can select which surface you want to include in your program control inflation. So I forgot one thing, that is the most important one, for car body. We should also give a name to our car body. Again I select the box, right click and give car body. Okay, so I would like to include our car body in the program controlled inflation. So it creates an inflation layer around our core body. Similarly, we also want inflation layer on our rod. So I included these two, and the remaining are excluded from the program controlled inflation. Now we click on update. Our update is done, and we will now see, as you can see, it has created an inflation layer over the rod and our car body. So it will accurately capture the boundary layer effects. As we had given number of cells as 5, so you can see it from here. Okay, we would like to again check our mesh quality, so we can proceed further. As you can see, the maximum skewness is 0.89, which is quite reasonable. So we would now close our meshing window and start our Fluent analysis. It is saving the database, so you should be patient and you should wait for the program to save your data. Now we are done with our design modeler meshing. Now we set up our solution. Here you can see that our dimension is 3D and it's blacked out because now you cannot change it from 3D to 2D, so you must select your analysis type at the start. This double precision means that it will go up to 16 digits after this decimal point, and it will obviously take more time, so we keep it single precision. It means that if this double precision is unchecked, it means single precision and it is up to 8 decimal points. The next thing is processing options, serial and parallel. Parallel means that if you have parallel computer and it has a number of 8 processors, 7 processors, 5 processors, you can select it from here, so it will use your number of cores. So I have a Core i3 laptop, but I'll just leave it to serial and click OK. Now it will load your mesh and Fluent server. Here we will specify our viscous models, boundary conditions, and everything which is related to our solution. Also our convergence criteria and also drag and lift sort of things. So it is loading the mesh, preparing mesh for display.